Okay, we're on to 4.1. Oof, it's nice to be in chapter 4. Things should get a little mellower for a bit. The only thing is we start in 4.1, which is going to be a lot of word problems. No, nobody's a big fan of those, but we're going to stick with right triangles. And then we'll go into 4.2, 4.3, where we'll start doing non-right triangles. That's some of the stuff people usually pretty much kick butt with. So, all right, let's get started. Let's just do the basics. So first we're going to start talking about solving a triangle. But let's see a couple of properties. Now, if we have a triangle, and the way we're going to set it up is right triangle. And I always draw my right triangles pretty much the same way. You can get the scale out of it on your own. And what we have is, well, we're going to call angles anything capitalized, okay? We'll capitalize our angles, so you know the difference. And then across from angle A will be side A. Across from angle B will be side B. And across from side C is angle C, but we already know what angle C is. It's 90 degrees because it's a right triangle. Now A and B, well, they don't have to be there. I could switch these and I could call this angle B and this side B, and then call this one angle A and this side A. Doesn't make any difference. The only one that's fixed is the C. So, cool. And then we should know a couple other things. I mean, I bet you didn't know this. A squared plus B squared equals C squared. That's sarcasm. And the angles A plus B must add up to be 90, because the sum of the interior angles of any two-dimensional triangle is 180 degrees. And we already know we have a right angle. We already know this is 90. So the other two angles must sum to be 90 degrees. Do you remember what that's called for angle A and angle B? If they add up to be 90 degrees, then what we call complementary angles. And we'll be back for that. There's something called the complementary angle theorem, which you only use if you like doing less work. If you like doing more work, don't even learn the complementary angle theorem. You'll be fine. You'll be fine. You'll get through the class. You just have to do extra work than the students that pay attention to it. But it won't stop you from anything. So here we go. So our first game is going to be what we call solve the triangle. It's also going to be the same game we do in 4.2 and 4.3. So what ends up happening is you get 3 pieces of information, and we want the other 3 pieces of information. All right. So let's see one. Let's see what 3 pieces of information are given. Oh, here we go. Solve the triangle. So we're given 3 pieces of information. 1, we have a 90-degree angle. 2, we have a 40-degree angle. And 3, we have a side. There's 3 pieces of information. And our job is to go find C, angle B, and side A. That's our game. But let's define our rules. Now, your homework will vary as far as rounding goes. But when you take a test with your instructor, you will find that we're going to round, because we got to do some rounding here. And you notice that there's no more radians in here. We're not going to talk about radians through chapter 4. We're just going to stick with degrees. That might make you feel pretty good. So what we're going to do is we're going to round sides. And again, your homework will vary. You have to read it. Your teacher stays very consistent when solving triangles. Sides, we round to 2 decimal places. And then we do angles to 1 decimal place. Okay. So like if you had a side and it was 2.657, we'd be like, nah, 2.66, because that number is bigger than 5. So we round up the next one. So 2 decimal places, just like if we had an angle. Make sure you use degree symbols, huh? What if we had 31.14 degrees? We're going to round it to 1 decimal place. Since that number 4 is less than 5, we would say it's 31.1 degrees. 1 decimal place. Please use degree symbols. Please, 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 I'm begging you to use degree symbols. Please, because if you don't, your teacher's going to go, oh, that's in radians. That's in radians. So all right, let's try this one out. So what do you think the first thing we should do here is? Because we got to solve stuff. Well, I'm going to tell you right now. if you're ever given an angle, well, shoot, you can go get the other angle, because we know that this angle 40 degrees plus b has to equal 90. So 40 degrees plus angle b is equal to 90 degrees. So we subtract our 40 over, and we get that b is equal to 50 degrees. Cool. Now, personally, I like doing this. I want to see my triangle. So you can list your solutions on exams as either just writing them down on the right-hand side, putting an equal sign and circling them, or you can just go through and make your own gosh darn triangle and fill it out and circle that at the end. All right. Now that we're here, and if we're using rounding, you got to have a calculator, right? Got to have a calculator. Make sure to get that in degree mode, okay? So now we need to go solve for something else. I don't know. Maybe let's go from 40 degrees. And let's go get A, because A comes before C. But all we have is we know the angle opposite, or we're looking for the angle, or the side opposite. Sorry for my misspeaking there. And we know the adjacent side from it. So I wonder, I'm saying, we want the opposite, and we know the adjacent. Think back to SOHCAHTOA. What has an opposite and an adjacent? Opposite, adjacent, tangent. Oh my goodness. So we can set this up and say that tangent of 40 degrees is equal to our opposite, A, over our adjacent, 2. Now, if we just multiply by 2 on both sides, we're going to get 2 times tangent of 40 degrees is equal to A. Well, let's punch that in the calculator. 2 times tangent of 40, enter. Two times tangent of 40, yeah, sorry. I was looking at my answer and just going, that seems wrong. And I get approximately 1.678. See, I write 3 decimal places down to round to 2. Because now we can take it and go, oh, that 8, it's 5 or bigger, so we got to call it 1.68. Well, there's our A. When we start making a list up top, I use the squigglies. You don't need to use the squigglies. I do, because I'm a math teacher. It drives me nuts. So now I can replace it and say 1.68. Cool. Cool. Well, we still need to get C. Now you have options. Do you want to do the Pythagorean theorem? You can. You can do the Pythagorean theorem. You could do this with sines or cosines to go get the hypotenuse. It's completely up to you how you want to do it. So I'm just going to think, whatever. I know A squared plus B squared is equal to C squared. And what's nice is all these lengths are positive now. They're positive. So I can just hit this thing with a square root and just punch it in my calculator. And there's C. Well, that's what I'm doing. I'm setting it down, saying the square root of 1.68 squared plus 4 equal to, and there would be. I get 2.611. Hey, that last one is smaller than 5. Therefore, we get 2.61. So there are our answers. We solved a triangle. Our first one. And I'm just going to put that in. So either or. This can be your solution. Just make the triangle. And then circle it, or I'm highlighting it and having fun shading it in as I go. Or you can just write it off as a list on the side. It's completely up to you. But that's our game. We're going to get really good at solving triangles. And non-right triangles. They're coming. So this is our first. Next, we're going to do some stuff where we're going to start solving for some angles. And it's going to be a process that we're going to repeat quite a bit. So I will see you in the next.